So here in this video we'll start with exercise 7.10. That's nothing but the 10th exercise under your chapter 7 integration. Okay, so here in this case we are going to evaluate by the method of substitution only, but it's going to be a definite integral. That's the only difference you have under this exercise here. So here we'll start with the first one, integral over 0 to 1 x by x squared plus 1 dx. So already I have told you in the previous videos how to do it by integration here. So what did I tell you actually here? First of all, check if the differentiation of the denominator gives the numerator, if it's a rational function here. So here if you see, you have it as x squared plus 1. So when you differentiate it, you will get it as 2x. So here that's what I have done here. So t is equal to x squared plus 1. Your dt by dx is equal to 2x. You will get dx is equal to dt divided by 2x. This is what you have here. Okay, so earlier we are used to changing only the integrands in with respect to t here. Now here from this case onwards, what you're going to do here is we are going to change the limit also in terms of t. Okay, so here we'll see how we can change the limit in terms of t here. What's the lower limit you get? X is equal to 0. So when x is equal to 0, what is the value of t? T is equal to 0 squared plus 1, that's nothing but equal to 1. Okay, now here the next one, x is equal to 1, the upper limit. So x is equal to 1, what will you get? T is equal to 1 squared plus 1, that's nothing but equal to 2. This is what you have here. So what is your I equal to here? I is equal to integral over, the lower limit is 1 and the upper limit is nothing but 2. It is nothing but x by t into dx. What is your dx there? It's nothing but dt divided by 2x. So here if you see your x and x, it gets cancelled and you're left with 1 by 2 into integral over 1 to t dt divided by t. This is what you have here. So here this is equal to 1 by t, 2 into what is integral of dt by t? That's nothing but equal to log mod t, of course you will have here, over the limit 1 to 2. Okay, now you know how to substitute the limit. I told you in the previous exercise itself how you substitute the limit here, upper limit minus the lower limit. So what will I write? 1 by 2 into log 2 minus log 1. So how is that I can write here? It is equal to 1 by 2 into log of, what will I get? Log m minus log n. I can write it as log of m by n. That's nothing but log of, what will I get here? 2 by 1. So here this one you will have it as half into log 2. This is how you get here. So this half into log 2, by the logarithmic power rule, this goes to the power, I can write it as 2 power 1 by 2. So what is 2 power 1 by 2? That's nothing but equal to log of root 2. So that's what I have written it as log of root 2. Is it clear? Yes. Now here the second question, integral over 0 to pi by 2 root of sine phi into cos power phi d phi. Okay, so here this is what we have here. So here again we'll see how we can integrate it by substitution in this case. So how is that I integrated by substitution here? So when you differentiate t, cos, you will get it as sine. But here if you see, you have sine only inside the square root. So it's not possible for me to use a substitution as t is equal to cos. But when I substitute t is equal to sine, what is that you get when you differentiate sine? You get it as cos. So see how we can do it here. It's integral over 0 to pi by 2 root of sine phi into, this one I have split and written it as cos power 4 phi into cos phi d phi. This is what you have here. Okay. Now here this one I can write it as cos squared phi the whole squared. Can I write it like this? Cos squared phi the whole squared, which is equal to integral over 0 to pi by 2 square root of sine phi. What is your cos squared phi? It's nothing but 1 minus sine squared phi the whole squared into cos phi d phi. Now my substitution with cos phi will work out actually here. So we'll see what you get. So put t is equal to sine phi. What is your dt by d phi equal to here? It's nothing but cos phi. You know what is your d phi equal to? It is equal to dt by cos phi. So now I told you have to change the limit. I told you here. What's the lower limit in the question? You have got 0. So when phi is equal to 0, you will get t is equal to sine 0. What is sine 0? That's nothing but 0. Now here what's the upper limit you get here? It's pi by 2. So when phi is equal to pi by 2, you will get t is equal to sine pi by 2 you get. So what is sine pi by 2 equal to here? It is equal to 1. So in terms of t, what is the lower limit here? It is 0. And what is the upper limit you get here? It's nothing but 1. Okay, so here we'll see how we can integrate it now. So here you have it as integral over 0 to 1. It's nothing but root t into 1 minus t squared into cos phi dt by cos phi. Of course it gets cancelled. I have substituted the limit here as 0 to 1. Don't forget to write the new limit in terms of t and don't write the old limit here. Okay. So here it is root t into, when I expand this, what will I get? It's a minus b the whole square, 1 minus 2t squared plus t power 4 into dt. The next step is what I'll have to multiply it. It's integral over 0 to 1. You will have it as t power half minus, what is that you will get here? T power half into t squared. So the power, if you see here, I can just add it if the base is the same. What is 2 plus 1 by 2? It's nothing but 2t power 5 by 2 you will get here. Now multiply these both. What will I have? It's t power half into t power 4. So the base is the same. I can add the power. You will get it as half plus 4. What is half plus 4? Actually here it's nothing but equal to t power 9 by 2. So I can write it as t power 9 by 2 dt. Now here if you see, it's feasible for me to integrate it. So here we'll integrate it and substitute the limit here. It's t power 3 by 2 divided by 3 by 2 minus 2 t power 7 by 2 divided by 7 by 2. What's the formula we have? Integral of x power n dx is equal to x power n plus 1 divided by n plus 1. This is what you have here. So here it's minus 2 t power 7 by 2 divided by 7 by 2 plus t power 11 by 2 divided by 11 by 2 over the limit. What will you get here? 0 to 1. Okay. Now we'll just substitute the limit. Anything to the power of 1 will be nothing but 1. So it's going to be 1 throughout here. So I'll have to just write the reverse of it. What will I get here? It's nothing but 2 by 3 minus this goes up. You will get it as 2 into 2. It's nothing but 4 by 7. Here again when it goes up, it's nothing but 2 by 11 minus the lower limit. Lower limit for whatever I substitute it is 0, 0, 0. So what will I get here? It's nothing but equal to 0. Now here I'll have to take the LCM of 3, 7 and 11. What's the LCM you get here? It's 231. So here in this case you will have it as 3 into 77 gives me 231. 2 into 77 is nothing but 154. Here again what will I get here? In this case it will be equal to, again you will have to multiply here. So what will you get in this case? Actually here again in this case it's nothing but equal to 7. Here again you will have, okay, so here that is what, here when you multiply you will have it as 132 is what you get here. Now here again here in this case what will I get here? 2 into what will I, sorry 11 into 21 is what you get. So 2 into 21 you get it to be equal to 42. So when you subtract and simplify it you will get it as 64 divided by 231. Is it clear? Okay. Now the third question, it is integral over 0 to 1 sine inverse of 2x divided by 1 plus x squared dx. Already under the differentiation implicit function itself I have told you, under that exercise itself, if at all you have it as 1 plus x squared, the basic trick you will have to remember that is your substitution is x is equal to tan theta. This was what I told you here. The same thing only we are going to use here. I can write it as I is equal to, because I cannot integrate it keeping it as it is. Okay, 0 to 1 sine inverse of 2x divided by 1 plus x squared dx. So what is the substitution I have taken here? X is equal to tan theta. What is your dx by d theta equal to here? It is equal to secant square theta you get here. Now when I cross multiply you will have it as dx is equal to secant square theta d theta. Is it clear? Now here when x is equal to 0, the lower limit, when x is equal to 0, okay, substitute it here, you will get 0 is equal to tan theta. What is your theta equal to? Tan 0 is equal to 0. So I can put theta is equal to 0. Is it clear? Now the upper limit x is equal to 1. So when I put x is equal to 1, what will you get? 1 is equal to tan theta. So what will I have? Actually your tan pi by 4 is equal to 1 you will get. So here what is your theta equal to here? Theta is equal to pi by 4. This is what you have here. So what's the lower limit you get here? 0. What's the upper limit you have here? It's nothing but pi by 4. Substitute it. I is equal to integral over 0 to pi by 4 sine inverse of 2 tan theta divided by 1 plus tan square theta, and here your dx is nothing but equal to secant square theta into d theta. Now what is this actually here? Again I have given the formula for this one. It's nothing but equal to sine 2 theta. So you have it as integral over 0 to pi by 4 sine inverse of sine 2 theta into secant square theta d theta. So this gets cancelled. It's left with integral over 0 to pi by 4 2 theta into secant square theta d theta. So what will I have? 2 into integral over 0 to pi by 4 theta into secant square theta d theta is what you have here. So you have it as, how is that you will have to integrate it? Yes, you have product of two terms you have. One is what actually an algebraic one and the other one is nothing but a trigonometric one. This is what you have here. So I'll have to use integration by parts. Okay, so here this is what I'll have to do it. So you know how to take the first one and the second one. By what formula I'll be using here? By the I-late formula. So here I'll be using the I-late formula in this case. So by using the integration by parts, what will I get? First into the integration of the second one minus integral of, what will I get here? D by dx of the first one into integration of the second one with respect to x you have here, okay, and the whole thing with respect to dx. This is what you have here. Is it clear? The whole thing with respect to dx. Now we'll see here it is with respect to theta. That's the only difference you get here. I'll just keep this 2 outside into integral of the first one. It's theta into integration of the second one. It's secant square theta minus integral of d by d theta of theta into integral of secant square theta d theta over the limit 0 to pi by 4. Don't forget that. I am integrating it. So I'll have to write it as over the limit 0 to pi by 4. Once I finish every integration here, after that only I will be substituting the limit here. Is it clear? So it is 2 into integral of, this is nothing but theta. What is integral of secant square theta? It's nothing but tan theta minus integral of d by d theta of theta is nothing but 1 into integral of secant square theta. What is that? It's nothing but tan theta d theta you get here. Okay, over the limit 0 to pi by 4. I cannot substitute the limit at, because here it's left without integration again here. So it's 2 into theta tan theta plus what will I get? What is integral of tan theta? Again this one you'll have to remind it here, because I have not given this formula anywhere specifically. It's nothing but equal to minus log of mod cos theta. This is the formula. So you will have it as plus log of mod cos theta over the limit 0 to pi by 4. So I will just substitute the upper limit. Now all integration is over. I can substitute the limit 2 into pi by 4 tan pi by 4 plus log into mod cos pi by 4 minus the lower limit. Don't forget the lower limit here, minus 0, and here minus the lower limit. So plus into minus will give you what? Minus log mod of cos 0. Got it? So when I multiply by this 2, what will you get in this case? Actually here you will have it as 2 into, okay, so 2 into pi by 4. Your 2 and pi by 4 it gets cancelled. Pi by 2 into tan pi by 4. What is tan pi by 4? That's nothing but 1 plus 2 into log of cos pi by 4. What is cos pi by 4? It's nothing but 1 by root 2 minus, this is 0. You will get it as log 1, because what is cos 0? That's nothing but 1. Okay, so here you will have it as log 1. What is log 1 actually here? It's nothing but equal to 0. So what's the answer you get here? It's nothing but pi by 2 plus 2 into log of 1 by root 2. Is it clear? Okay, so be careful when you integrate it by parts, especially when you apply the limit. You will have to be very careful here. Only after you integrate the whole thing you will have to apply the limit here. Okay, see how I have done here. Only after that you will have to apply the limit in this case. Okay, now the fourth question, integral over 0 to 2 x into square root of x plus 2 dx. There are so many two ways of doing it, but in the text if you see here, it's mentioned as, the hint given is put x plus 2 is equal to t squared. That's a hint given to us. So using this hint itself we will proceed here with the problem, because the question given is integrate the following integrals by the method of substitution. Okay, so here we'll use the substitution method itself, the hint whatever they have given. So by the hint, it's x plus 2 is equal to t squared. So when I differentiate it, you will have it as 2t into dt by dx is equal to 1. So when I cross multiply, what will I get? Your dx is equal to 2t dt. This is what you have here. So now substitute x is equal to 0, the lower limit. So when I substitute the lower limit, what will I get? T squared is equal to 0 plus 2. So you will get t is equal to root 2. This is what you have here. Now the upper limit, x is equal to 2, you will get t squared is equal to 2 plus 2. So you will have t is equal to 2. Of course you will get it as plus or minus, but please take only the positive value here. So I is equal to integral of the lower limit will give me what here, root 2, the upper limit will be nothing but 2, and here what is your x here? From this you know what is your x equal to. What is your x equal to here? It's t squared minus 2. So I can write it as t squared minus 2, and here you will have it as square root of t squared, and what is your dx equal to here? Your dx is equal to 2t dt. You understood? Okay. Now t squared minus t, what is this actually here? It's nothing but t. So 2t into t will give you what? 2t squared. Now multiply it. What will I get? Integral over root 2 to 2. It is 2t power 4 minus 4t squared dt. So here we'll integrate it with respect to t. What will you get? 2t power 5 by 5 minus 4t cube divided by 3 over the limit root 2 to 2. Be careful when you resubstitute the limit in terms of t also here. See, write the lower limit, the upper limit here. So write that correctly. Okay. So now we'll integrate it, and then we have integrated. Now the next step is to substitute the limits here. So here it is equal to, applying the upper limit, what will I get? 2 into 2 power 5 by 5 minus 4 into 2 cube divided by 3 minus the lower limit. Actually what is that you have actually here? It is 2t power 5 by 5 you have here minus 4t cube divided by 3 over the limit root 2 to 2. This is how you get here. So I have substituted the upper limit minus the lower limit. So minus the lower limit, it becomes minus here. 2 into root 2 the whole power 5 divided by 5, minus of minus, it will be nothing but plus 4 into root 2 the whole cube divided by 3. What is 2 power 5? It's nothing but equal to 32 into 2 is nothing but 64 by 5. Here it is 8 into 4, it's nothing but 32 by 3. What is root 2 the whole power 5? I can write it as root 2 the whole power 4 into root 2. What is this? It's nothing but 2 squared into root 2. So you will have it as 4 into 2. That's nothing but 8 root 2 by 5. Here you will have this as root 2 the whole squared into root 2. So what will I get here? It's nothing but 2 root 2. So 4 into 2 is what? 8 root 2 divided by 3. You understood? Okay, so we'll just take the LCM of these two terms and these two terms here. What's the LCM you get here? It's 15. 64 into 3 is 192 minus 32 into 5 will give me 160 divided by 15, plus here again the LCM is nothing but 15. First I have written the positive term here. 8 into 5 is nothing but 40 root 2 minus what will you get? 24 root 2 divided by 15. So what will I have here? It's 32 by 15 plus 16 root 2 divided by 15. 40 root 2 minus 24 root 2 will give me what? 16 root 2 divided by 15. This is what you have here. Yes. Now here we'll start with the fifth question here. Integral over 0 to pi by 2 sin x divided by 1 plus cos squared x dx. So what is integral over 0 to pi by 2 sin x divided by 1 plus cos squared x dx you have here. So again in this case by the method of substitution, see if anything you differentiate it here, you can get, yes, when I differentiate cos, what will I get here? I will get it as sine, okay, minus sine. But don't substitute it as 1 plus cos squared x. If you had it as 1 plus cos x, then I can use that substitution. But here if you see it's 1 plus cos squared, so it's not possible for us. So you will put t is equal to cos x. dt by dx is equal to minus sin x you will get here. So what is your dx equal to? Minus dt divided by sin x. Now we will correspondingly change the limit here. When x is equal to 0, your t is equal to cos 0, that's nothing but equal to 1. Upper limit, when x is equal to pi by 2, t is equal to cos pi by 2. What is cos pi by 2 equal to here? It's nothing but equal to 0. So what is your I equal to here? Integral over, the lower limit is nothing but 1. What's the upper limit you have here? It is 0. It is sin x divided by 1 plus t squared into minus dt divided by sin x. So your sin x and sin x, it gets cancelled. It's minus integral over 1 to 0. It's dt divided by 1 plus t squared. So what will you get? It's minus of tan inverse of t over the limit 1 to 0. So it's minus of tan inverse of 0 minus tan inverse of 1. So what will I get? What is tan inverse of 0? It's nothing but 0. What is tan inverse of 1? It's nothing but pi by 4. So here minus of minus, what's the answer you get here? It's equal to plus pi by 4. Okay. Yes, so here we'll start with the sixth question. Integral over 0 to 2 1 by x plus 4 minus x squared dx. Okay, so here we are going to start with this one here. So it is equal to integral over 0 to 2 1 by you can just rewrite it as minus x square plus x plus 4. I already told you in the one exercise under integration here, if at all you are not able to split it by using partial fractions, and if you have in the numerator s1, what is that I will have to do here? I will have to write this in the complete form. So what do you mean by saying the complete form here actually here? Yes, here you will have to write it as x squared minus a squared or a squared minus x squared. So for that the coefficient of x squared must be 1 here. I'll just take the minus sign outside. It's x squared minus x minus 4 dx, which is equal to integral over 0 to 2 1 by the minus sign, you can take it out, divide the coefficient of x by 2. So what will I get here? It's 1 by 2. So this 1 by 2 I will add and I will subtract, taking it the square here. So okay, squaring it, and I'll have to add and subtract it. Integral over 0 to 2 1 by minus of x squared minus x plus 1 by 2 the whole squared minus 1 by 2 the whole squared. Already you have a minus 4, that minus 4 I have written. This is the only thing I have included. Now you consider the first three terms, a squared minus 2ab plus b squared. So what's the formula you get here? It's integral over 0 to 2 1 by minus of, it's x minus 1 by 2 the whole squared minus 1 by 4 minus 4. This is what you get here. So what is minus 1 by 4 minus 4? It's nothing but equal to minus 17 by 4. Remember, I have one this minus sign outside. Already I have mentioned, if you have a minus sign, finally I'll have to multiply that minus sign actually here. That's what I told you there. It's integral over 0 to 2. Now I'll multiply the minus sign. Minus into minus is nothing but plus. So you can write it as root of 17 by 2 the whole squared minus of x minus 1 by 2 the whole squared. So what's the formula you get? Integral of dx divided by a squared minus x squared. What's the formula? 1 by 2a into log mod of a plus x divided by a minus x. This is the formula you have here. Okay. Remember, what is your a? Root of 17 by 2. What is your x? X minus 1 by 2. Okay, so here we'll just substitute it here. After this, it's just only the simplification part actually here. Only that is lengthy here. The integration is very simple. 1 by 2 into root of 17 by 2, because your a is equal to root of 17 by 2 log of mod a. What is your a? Root 17 by 2 plus x minus 1 by 2, because your x is nothing but x minus 1 by 2 divided by a. What is your a here? Root 17 by 2 minus. So what will I get here? Minus x. Minus of minus will give me what? Plus 1 by 2 over the limit 0 to 2. Got it? So here we will substitute the upper limit minus the lower limit. So here if you see, your 2 and 2 gets cancelled. It's 1 by root 17 log of mod root 17 by 2. When I substitute it, you will get it as plus 2 minus 1 by 2 divided by root 17 minus 2 plus 1 by 2 minus log of mod root 17 by 2. This becomes 0, the lower limit, minus 1 by 2 divided by root 17 by 2. This also becomes 0. So you will have it as plus 1 by 2. This is what you get here. Okay. So it is 1 by root 17 into log into mod of, what is 2 minus 1 by 2 actually? Here you will get as 3 by 2. So this 2 is common here. So I can write it as root 17 plus 3 by 2 divided by minus 2 plus 1 by 2. What will happen here? It will be nothing but minus 3 by 2. So I can write it as root of 17 minus 3 by 2 minus log of, this can be written as root 17 minus 1 by 2 divided by root of 17 plus 1 by 2. So everywhere you see this gets cancelled here, this 2. So you are left with 1 by root of 17 log of mod root of 17 plus 3 divided by root of 17 minus 3 minus log into mod of root 17 minus 1 divided by root of 17 plus 1. Now the next step, you know what is log of m minus log of n. What is it equal to here? It's nothing but log of m by n. Okay. So this is your m and this is your n. So if I write it as log of m by n, what will I get? It will be nothing but the reciprocal of this. Division of this will be nothing but the reciprocal of this fraction here. So I can write it as 1 by root of 17 log of mod, what will I have here? It is root 17 plus 3 by root of 17 minus 3 into root of 17 plus 1 by root of 17 minus 1. Got it? So it's 1 by root of 17 log into, we'll multiply these both. Root 17 into root 17 is nothing but 17 plus root 17 into 1 is nothing but root 17 plus 3 into root 17 is nothing but 3 root 17. This when you multiply it's plus 3 divided by root 17 into 17 is what? 17. Root 17 into minus 1 is nothing but minus root 17. When you multiply this it's minus 3 root 17 and when you multiply this it is nothing but plus 3. Is it clear? So here 17 plus 3 is what? Here I have written it as 1 by root 7. So 17 plus 3 is 20 plus 4 root 17 divided by 20 minus 4 root 17. So it's 1 by root 17 log of this 4 can be taken outside. It gets cancelled there. So it's log of 5 plus root 17 by 5 minus root 17. So here this one we'll just rationalize it. We'll simplify it and then we'll do it. As I told you earlier, after this step is only simplification. Only for that reason this problem is lengthy and not for your integration. Okay. So here you have it as log of mod 5 plus root 17 by 5 minus root 17. Of course it's into 1 by root 17 here. So to rationalize it, what will you do? Multiply and divide by the conjugate of the denominator. So what's a conjugate of the denominator? You have 5 plus root 17. So you will have it as 1 by root 17 log into mod of 5 plus root 17 into 5 plus root 17 divided by 5 minus root 17 into 5 plus root 17. So the numerator, what's the formula? A plus b the whole squared. Here if you see it's nothing but a squared minus b squared. So a plus b the whole squared is what? 5 squared. It's 25 plus 2ab. 2 into 5 root 7. That's nothing but 10 root 17 plus root 17 the whole squared. It's nothing but 17 divided by a squared. What is a squared? 25 minus b squared. What will you get? Root 17 the whole square. That's nothing but 25 minus 17. So you will have it as 1 by root 17 log of mod 25 plus 17 is what? 42 plus 10 root 17 divided by 25 minus 17 is nothing but equal to 8. So here if you see it's divisible by 2 throughout. So it's 1 by root 17 log of 21 plus 5 root 17 divided by 4. This is the final answer. So as I told you earlier, only the simplification part takes much time, not your integration. Okay. Now your seventh question, integral over minus 1 to 1 by x squared plus 2x plus 5 dx. So I is equal to integral over minus 1 to 1 by x squared plus 2x plus 5. As I told you for the previous problem, first of all if you have it as 1 by anything, any rational function, check if you can factorize it. You will not be able to factorize it actually. If you are not able to factorize it, bring it to the complete form. So how do you bring it to the complete form? Divide the coefficient of x by 2. Add that and then subtract it. So what will I have? Integral over minus 1 to 1 by x squared plus 2x plus 1 the whole squared minus of 1 the whole square plus 5. So what will I have here? It's integral over minus 1 to 1 by this one will be nothing but a squared plus 2ab plus b squared. So what will I have? A plus b the whole squared is nothing but x plus 1 the whole squared. Here if you see you have, in this case it's minus 1 plus 5. What will I have? It's nothing but 4. So what is that you have? Integral over minus 1 to 1 by x plus 1 the whole square plus 2 square dx. What's the formula you get here? Integral of dx divided by x squared plus a squared. What's the formula? It is equal to 1 by a into tan inverse of x by a. This is the formula you have here. So it's 1 by a. What is your 1 by a here? It's nothing but 1 by 2 into tan inverse of x. What's the value of x here? X plus 1 by 2 over the limit minus 1 to 1. So it's 1 by 2 into tan inverse of, applying the upper limit, 1 plus 1 is what? 2 by 2 minus tan inverse of minus 1 plus 1 is what? Here if you see it is 0 by 2, that's nothing but 0. So you will have it as 1 by 2 into tan inverse of 1. What is tan inverse of 1? It's nothing but pi by 4 minus 0. When you multiply it, the answer is equal to pi by 8. Okay. Question under this exercise, integral over 1 to 2 1 by x minus 1 by 2x squared into e power 2x dx. So when you see it itself, you know that very well it's not possible for us by substitution here. So only possibility is what? By integration by parts. Okay. So before integrating it by parts, what I'm going to do here is I'll just split it as two separate integrals here. Integral over 1 to 2 1 by x into e power 2x minus 1 by 2x squared into e power 2x dx. So split it as two separate integrands here. It's integral over 1 to 2 1 by x e power 2x minus integral over 1 to 2 1 by 2 x squared e power 2x dx. Okay, so when I integrated it by parts itself, I told you if you have two integrands here, okay, what did I tell you? Check if what you differentiate, you will get the second term actually here. So when I differentiate 1 by x, what will I get? It's minus 1 by x squared. So you're getting it here. So I will use only parts only for this one and not for this one here. We'll keep it as it is here. So when I use the parts, this is inverse and this is exponential. So this is the first one and the second one. So I've written already the formula here. It's 1 by x into integral, the second one, e power 2x dx minus integral of d by dx of the first term. That's nothing but 1 by x into integral of what will I get? E power 2x dx. Okay, so here this is what you have here, e power 2x dx over the limit. What will I get here? It's 1 to 2 minus the second integrand. I have written it as it is, integral over 1 to 2 1 by 2 x squared e power 2x dx. Now here it is equal to 1 by x into integral of e power 2x. What is it? It's e power 2x by 2 you have here, minus integral of what is d by dx of 1 by x? It's nothing but minus 1 by x squared. What is the integral of this? It's nothing but e power 2x by 2 over the limit 1 to 2 minus this integrand. I have written it as it is. This is nothing but not integration here, the original integral, the second integrand. I have just written it as it is. Okay, now I am going to apply the limit only for this. I'll just write this as 1 to 2. Okay, so it's 1 by x e power 2x by 2 over the limit 1 to 2. Minus into minus is nothing but plus integral over 1 to 2 1 by 2 x squared e power 2x dx minus integral over 1 to 2 1 by 2 x squared into e power 2x dx. Now you see here very beautifully these two gets cancelled here. You'll have to just substitute the limit here. What will I get? It's upper limit 1 by 2 into 2. It's 1 by 4 into e power 2 into 2. What will you get? It's e power 4 minus the lower limit minus 1 by, what will I get here? 1 into 2. That's nothing but 1 by 2 into e power 2. So when I take e power 2 divided by 2 outside, what will I have? E power 2 by 2 into, it's nothing but e power 2 by 2 minus 1. This is what you have here. Okay.